Okay, this video I'm going to do something a little bit different again. I've got an old Galaxian board that was very kindly given to me. This is a bootleg one, and when I power it up, this is what I'm getting on the screen. As you can see, it's just doing not a lot. Now, this is the board here. It wasn't in good shape to start with. It had a capacitor missing there, as you can see. I've had to replace a capacitor because the clock signal was not really working. Now, I haven't really done very much with this board so far. More or less just found out there was no clock, changed the capacitor. I've now got a clock signal, but you can see there's missing graphics ROMs there. The daughter board has got the stuff, it's all plugged in, as you can see, with the ribbon cables. The Z80's at the back there, and this is one that's actually got a lot of wires soldered to it. It's configured as a Konami Classic at the moment, and this basically is how I got it. So what I'm going to do is I'm going to pop the processor out of it, and I'm going to plug my tester into it, and then we'll interrogate it. Now, I haven't got the schematics to hand. I haven't even looked at the schematics, to be honest with you, so I've not got the schematics. So what we're going to do is just do everything using just the tester and see what we can find out about this board and what's maybe happening to it. Okay, so I'll stop the video at the moment and then I'll continue it once I've got my tester hooked up. Okay, processor's removed, tester's plugged in again at the back there. Now on the screen we're getting this, which is telling me straight away that the board is static, so it's just generating video but it's not doing anything because the processor's been removed. And up the screen we have the tester. So what we can do to start with is, let's just make sure it focuses. The first thing I'm going to do is I'll clear this out of the way. I'll move this down a little bit as well because it's a bit of a stretch to get there. And I think the first thing we'll do is we'll do a memory map and see what it's telling us. So simply type map. I'm going to set it to default, which will be 1K blocks, and we have a memory map pop up. So let's have a look. The blue ones are not used, as you can see. Keep going up. Oh, we have some sort of ROM area appearing. Then we have some RAM. This is normal RAM because it's green, so it's just like work RAM or whatever. That's showing up that. We also have video RAM showing up at address 5000 by the looks of it. Now these are 1K blocks, so that's 2K of video RAM, not used. Some more RAM that it claims is either write only or it's possibly bad. And then we've got right up to the ROM space. So we've got an interesting map. So I think we'll try testing some of the RAM. So we'll go and see if the video RAM works. So it's address 5000. So we'll set this up to address 5000. Like so. Write the address, so we load it in, and then we have to go down to this window here and just type in RAM test. And we'll test 0800 in hex, which is, that's 2K, which will be the full RAM, and we'll see what happens. Well, it looks like the video RAM seems to be working okay, because it's tested that. So we can also go and check the next lot of RAM. I'm going to do the memory map again because I can't remember where it was. Sorry. So go back. You can do the memory map anytime you like, it doesn't affect anything. So the memory map is, the RAM we want to test now is at 5.8. We'll leave the other RAM, but we'll try this RAM. So again we need to make that 5.8, which it is anyway, but we'll just set it. And we'll do the same again. See if it tests a normal memory this time. This is work memory. This is not memory that's shared with a video circuit. That's why it indicates it's green. So basically it's just normal memory that's on the address range of the processor. Let's pass that as well. So it looks like the memory appears to be okay. Okay, so that's fine. So what we can now do is let's check and see if we can read some ROMs. So we'll set it to address here. I'm going to just clear all that in the window, and we'll try and read some ROMs, which will be, let's type in FF and see if we can read that in. It doesn't look very healthy at first glance. As you can see, the data appears to be all sort of F something, whatever. So I don't think that's valid code, to be honest with you. You can't imagine it being like that. Normally you'd expect normal numbers and things, not all F something or other. So I think there's a problem reading the ROM first of all. We can check and see if the data bus has actually got any stuck pins. Whoops. So if we set the address to 0, and what we'll do is we'll just see. So you just type in stuck, and I'm going to go and check for, say, maybe 2K. Stuck will basically check all the data bits, the data pins, so D0 to D7, and it'll be looking for them to change state. If any of them don't change state, then it will suggest they're possibly stuck. It tells me already that there are possibly 4 stuck bits, which is D4, D5, D6 and D7. D0 to D3 appear to be okay, so what it's telling me is those 4 bits are not really changing, which would indicate why we're reading back F something all the time, because that in hex would be F, so they're probably all stuck high looking at it. Okay, so we might have a problem with the data bus. We will need to check the address bus as well to the ROMs, and we'll do that using the probe and trace pins. I'll stop this video and then I'll start another video soon, which will be basically checking the data and the address buses of the board, and we'll see if we can get anywhere with that and see if we can identify any faults. And this is all getting done without any schematics, as you can see. Okay, so I'll stop this video and I'll resume it soon when we get on to testing the data bus and address bus.